Hello everybody. Today we're going to continue working with finding equivalent fractions using division and taking smaller fractional units and simplifying them into larger fractional units. So let's take a look. Last week we started to talk about how we can take smaller pieces like you see here where I have all these twelfths, and instead of working with a fraction like 10 twelfths where we've got really tiny pieces, we can do what's called simplifying and trying to make those fractional parts simplify and trying to take those fractional parts and making them into larger fractional parts. I think most of us in our heads have a good idea of what 1/2 looks like, 1/3, 1/4. As we get to smaller units like tenths, twelfths, it's harder to visualize that. So simplifying is helpful because it allows us to work with some fractions that we're more comfortable with, fractional units, like halves, thirds, fourths, fifths, and maybe even sixths. Beyond that, it's a little hard to visualize. So we're going to take a look at how we can do this today. Our first example asks us to show 10 twelfths. So I want to take a look at this because I've made a 3x4 array, so I have 12 parts. If I shade 10, the way we were kind of doing it last week, I can go down and go 3, 6, 9, and then 1 extra. And you may find, that's going to be a little awkward for finding equal groups, because last week we talked about when we want to do division, we want to think about making groups of something, right? And so naturally, we might look at this and want to make groups of 3. But if you look, that's not going to work. Excuse me. Excuse me. Excuse me, guys. Sorry. It's not going to work because if we do break them into groups of 3, we have a group of 3 that has some of it colored and some of it not shaded, and we can't have that. So that's not going to work. And here's why. We know that we can't do 10 divided by 3 equally into equal groups. We could with remainders, but we're not dealing with remainders and fractions. So we can't make it into groups of 3. So today, your job is to not just automatically take columns, but to think about what number can I divide both of my numbers by equally. So if I look at the number 10 and I look at the number 12, and I think about what numbers both of them can be divided by, my first thought is 2. I know I can break a 10 into 2 equal parts and a 12 into 2 equal parts. So I'm going to make groups of 2. And it doesn't matter how you make these groups of 2. So if you want to do it like this, here's a group of 2, here's a group of 2, here's a group of 2, here's another group of 2 and a group of 2, that's fine. And then a last group of 2. The key piece is to make sure that you don't have any groups that have some shaded and unshaded parts. We have to make sure that if you circle a group, all of the parts are either shaded or all of its parts are not shaded. Now we can go ahead and do our division. How many of my groups are shaded? Well, 10 divided by 2 is 5, and indeed I have 1, 2, 3, 4, and 5 groups shaded, and that's my dog wanting to play. Keep that in mind for the end of the video, and you can skip one question if you tell me what my dog wanted to do in the middle of making my video today. Not playtime right now, Finn. Sorry, buddy. Okay, so now I can do 12 divided by 2, or 6, because I have 6 groups. Okay, so today it's not just a straightforward make those columns. You have to kind of think to yourself what groupings would make sense. Let's take a look at another one. In this example, I've given you the fraction and the division sentence, and I want to see if you could model it. So the first thing you're going to do is you're going to start by just making an area model with 10 equal parts, 6 of which are shaded. So I'm just going to go ahead and draw a rectangle here. Oops, I'm going to keep my marker down so that I can make it a nice rectangle. Okay, and I'm going to show you that we can do this lots of different ways. So it doesn't matter how you draw yours, as long as it represents what I'm asking you to represent. Okay, so if I want to make 6/10, one way I can do it is I know I can do 5 parts, 1, 2, 3, 4, and draw a line across. That makes my tenths. I can shade 6 like this. And then it says I'm dividing it into groups of 2, so I'm going to make my groups of 2. And you don't have to necessarily draw those ovals, but it's nice for a visual. And sure enough, I end up with 3 shaded ovals and 5 total shaded ovals. So that's one way to go about it, okay? Maybe you look at it a little differently. Maybe you visualize something that looks like this. Maybe you think, I'm going to go 5 rows and 2 columns. I still have tenths. I can still shade 1, 2, 3, 4, 5, 6 of my tenths. And now I'm just looking for groups of 2, right? Because it says divide into groups of 2. Now remember, can I do this? I can't because one is shaded and one is not shaded. Remember, you have to find those groups that are either all shaded or all not shaded. But now I have 5 groups of 2, 3 of which are shaded, okay? Does that make sense? Right? So it doesn't matter how you draw it as long as it represents what we're asking. So another way to show it would be like this. Let's say I did just like what I did before, but instead of shading my 6 in that way, maybe I realize, hey, if I'm making groups of 2, it's better to shade my 6 like this. Then I can easily find groups of 2 by going across my rows. So, okay? But in any of those cases, I have 5 groups of 2 because I divided into 2, and 3 of them are shaded. Okay? Let's take a look at one last one. 8/12. What if I asked you to reduce 8/12, or basically simplify 8/12 into a nice, easier fraction? In other words, make some greater fractional parts. So the first step, again, is you're going to get your area model going, and you're going to show 12s. Once again, there's lots of different ways to do 12s. Maybe, this is how I would think of it, I'm going to do 6 times 2 is 12, right? So I'm going to make a 2 by 6 array. Okay, and if I shade 8, I'm going to go 2, 4, 6, 8. I easily see here that I can divide each number by 2, whoops, because I can make groups of 2. They're very clear to me on my visual, right? I can easily make groups of 2, which means my new fraction would end up being 4/6, because 8 divided by 2 is 4, and 12 divided by 2 is 6. Well, some of you might say, but wait a minute. I decided to do this. I know that I can make a 4 by 3 array for my 12ths, and I can highlight 8 of them by doing this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got 8/12. Well, this time, as I look at it, I go, I can actually divide both parts by equal groups of 4. 1, 2, and 3. So this time I decided to divide by 4 because that's what my visual representation kind of lent me to think about. And what does that equal? 8 divided by 4 is 2. 12 divided by 4 is 3, so I get 2/3. Well, that's okay. 4/6 is equal to 2/3, which is also equal to 8/12. What was different was just what we divided by. The key piece here, guys, is to just look at your numerator and your denominator and think about what number can both of my numerator and my denominator be divided by. So if I look at something like the fraction, let's say 6/12, if I want to look at 6/12, I can think, okay, what number can both 6 and 12 be divided by? Well, I know 6 can be divided by 2, and I know 12 can be divided by 2, so I could go ahead and try dividing both parts of my fraction by 2, and I end up with 3/6. Okay? I might also recognize, hey, both of these numbers are divisible by 3, because I know I can do 6 divided by 3 and 12 divided by 3. So I could choose to use 3 as a way of simplifying my fraction. So 6 divided by 3 is 2, 12 divided by 3 is 4, and I get the answer of 2/4. Now recognize something, guys. We can even do it one more time. I know 6 is divisible by 6, and so is 12, so I could do 6/12 and divide both parts by 6. I get 1/2. We know all three, actually all 4 of these fractions are all equivalent because they're all equal to 1/2. 6 is half of 12, 2 is half of 4, 3 is half of 6, and obviously 1 is half of 2. Any of these fractions are correct. They are all equivalent. It was just depending on what we decided to divide by that got us our different fractions. Okay? So for today, you're going to go and do some more equivalent fractions using division. One of the pages they're going to ask you to model. And if you can tell me what my dog wanted to do in the middle of our video, you can skip one single question, not a whole slide, one question, and you need to write what my dog wanted to do. Good luck. Have fun.